right? So power is work done per amount of time, work over time, and then the unit is watts. So number 10. So if you know the power output of an object, what else would you need in order to determine the work that it's going to do? Luke, what do you think? What do you need to know besides, if you want to know power, what do you need to know, or if you know power, what do you need to know also to figure out work?
Time.
Yes, the other thing you need is time. You need to know the time as well. Okay, and the reason for that is power equals work over time. So if you know power and you're solving for work, you also have to figure out time. You also got to know what time is. All right, number 11. Which one does more work, a 300 horsepower engine or a 150 horsepower engine? Sebastian, what do you think? Which one is going to do more work, 300 or 150?
300 because it's actually doubling the work of the 150 horsepower.
Let me be careful with the wording. It's not doubling the work. It's doubling the power, because this is horsepower is a power unit. So you are right. It is doubling the power, and maybe that means it's doubling the work. But I do want to be specific with the wording. It isn't double the work. It's double the power. Okay? All right, so you said 350, it's double the amount of power. So our 300 versus 150, it's double the amount of power. So maybe that means it's double the amount of work. Good. Anyone got a different answer? Luke?
I said the 150 horsepower.
Okay, why?
Engine because it has to do more work to be able to do the same thing as
Okay, so it has to. So if you want to do it, maybe you have to do more work because the power's less. Maybe that means you need more work in order to accomplish the same thing. Okay, that's not bad. Any other answers? Good. The answer is you don't know. Yep, this is one of those questions again. The answer is you don't know. So here's the thing. They're both exactly right. Okay? They're both exactly right. In order to get the same amount of stuff done, the 150 horsepower is going to have to do more effort. But that doesn't necessarily mean more work. Okay? I'll show you another way that we can look at it. Likewise, just because it's got more power doesn't mean it necessarily has to have more work. For example, if I have a 150 horsepower engine, okay, so we got 300 is equal to work over time. We got 150 is equal to work over time. Let's say that we turn this engine on for 2 seconds. If we have a 300 horsepower engine, that means that we do 600 joules of work, right? 600 divided by 2 gives you 300. This is the set value. So if we turn the engine on for 2 seconds, but what if we turn this engine on for 100 seconds? Well, if we do that, I want to make sure I'm not messing up my math. It's early. That does 15,000 joules of work. So we don't know. We need to know time. I tried to hint at that a little bit with the previous question, but I also didn't want to be too obvious. You don't know. You need time. If you don't know the time, you cannot make any predictions about work or anything like that. Okay? Because power is the rate at which you do work. If you do work at a lower rate, that's what 150 is. It does work at a slower rate. That doesn't mean you do less work. It just means you have, and this is kind of what Luke was saying. You just had the wrong conclusion, but you had the right idea. Which is, you would have to do more stuff in order to accomplish the same thing. Okay? But this question is just wondering which one does more stuff. Well, you don't know unless you know how long you do it for. Okay? So I wanted to kind of really emphasize that point with this question, that It really, really matters on the time and the work. It's not just one or the other. You have to know both. Okay, and this one, do you think the company bills you for power or energy? They measure it in kilowatts. The book talks about they measure it in kilowatts or megawatts. Technically, they use kilowatt hours, but it's not a big difference. They measure your bill in power. Work done for amount of time. So it's the work done by your household electronics divided by how long they do that work for, right? So if you leave a light bulb on for a long period of time, it'll do more work and therefore draw more power than, say, if you leave it off or whatever the case may be. And if you think about that, that kind of makes sense. They're not measuring energy. And the reason they're not measuring energy is the stored stuff, that what you can do. They're not measuring that. They're measuring what's actually being done, but not just what's being done, but the rate at which you're doing it as well. A washing machine will use power will use the energy at a much higher rate, and therefore it draws more power. So it's power that they're measuring, and the reason why we know is because they're usually using kilowatts, which is a power number, not an energy number, which is good because if they charge you by how much energy, the bill would be a lot higher because energy is lost on the way to your house. So if they were measuring it, they'd be like, oh, wow, you used a ton of energy. You're like, well, I didn't get that much. They're like, yeah, well, too bad. Sucks to be you. So it is measuring power, the rate at which you're using it, as opposed to what you're actually using, the value. Okay? Good. All right. Let's go ahead and jump in to the next thing, which is... Oh, but let's actually stop this.